So it's worth spending a minute or two to think about how you would define the word system. So we use this word in English, and we're going to use it in a fairly technical way this semester and in a couple different ways. And so it's worth pausing here for a second and thinking about what you would answer if I asked you to define the word system. So probably the most useful definition of a system at this point is that it is the set of interacting components. And there are many different kinds of systems, but really kind of the take-home point is that by putting all of these components together, we create something that is more than the sum of its parts. And part of the goal here is to start understanding how all of those parts work together. So here are two systems, a jet engine and a computer. The observation here that I'd like to make is that if you talk to an aerospace engineer, they see the jet engine, but they also see all of the components that make up the jet engine. Similarly, as computer scientists, we should be able to look at a computer and see the computer, but also see all of the individual components inside that computer and how they interact to form that larger computer system. So we'll define a computer system as a set of multiple hardware and software components that work together to run user applications. We use complex computer systems every day. You're watching this, no doubt, on a computer system. And so our goal for this semester, or one of our goals for this semester, is to kind of peel back some of that complexity and see a little bit of what is under the hood of a computer system. So for instance, we're going to end up defining things like processes and files, and these are maybe things that you've talked about before, but now we're going to look at them in a lot more detail. And at its core, these things are examples of one of the primary tools that we as computer scientists have for dealing with complex systems, which is the idea of abstraction. So an abstraction is sort of this fake view of reality that actually helps us because it reduces the complexity that we have to deal with at any given time. And the idea is that we're going to kind of ignore the details and we're going to focus on interfaces. How do the different components of our system work together? And you're used to doing this all the time. If you drive a car, you don't need to necessarily know about every single piece of the steering system. That has been sort of abstracted away to this thing that we call a steering wheel. And that allows you to manage the complexity of the system and make it useful to do the things that you need it to do at any given point. And this is especially important in very large, complicated systems. And what I'm going to assert to you at this point is that understanding these abstractions, so understanding what your computer is doing under the hood, improves your ability to use the computer effectively and to fix things when they go wrong. So one little caveat here, there are two different terms that are related to each other that we're going to use over the course of the semester, and I'm going to distinguish between software systems and system software, and it's a little frustrating that in English these are so similar to each other. The former is a set of software components, so it is a system of software. The latter is specific software that provides services to other software, and we'll be talking about both of these this semester.